Assalamualaikum and hi. My name is Nur Zahira binti Adi Azmin with metric number 207197.
My name is Nuramirah Ilyana binti Muhammad Noor with metric number 207887.
My name is Maizatul Nisha and my metro number is 206210.
Hi, my name is Siti Fatimah with metric number 207873.
Hi, my name is Nur Alieya Hanim binti My metric number is 207226. We are going to present our group assignment. Let's start with question 1.
Question number 1. Let function z equal to zxy and w equal to wxy be defined implicitly in the equation 2x squared plus y squared plus z squared minus zw equal to 1 and x squared plus y squared plus 2z squared plus zw equal to 8. Find the expression of del z over del x and del w over del y. Step number 1. Let the functions xy and wxy be expressed implicitly in the system of equation f x y z w equal to 0 and g x y w z equal to 0. Step number 2. We find the partial derivative of the function f and g with respect to x, y, z, w, and we got the equation below. We got that answer. Step 3. When we get all the expression required for find the Jacobian fg with respect to xw and the Jacobian fg with respect to zw, the value given as below. Next, we substitute the value of partial derivative that we obtained from the step 2 into the formula. And we get this answer. Next, we find the determinant of the matrix and we get negative 4xx plus 2xz over 2z square minus zw plus 4z square plus zw. And finally, we simplify and obtain the answer for del z and del z over del x, which equal to negative x over z.
Okay, next we move to the next expression to find the del w over del y. We use the Jacobian concept to find the term of del w over del y based on given system equations. Then we got negative del fg with respect to del yz over del fg with respect to del wz. Then we substitute all the expressions or partial derivative that required for finding the Jacobian del fg over del yz over del fg with respect to del wz. And then the value is given as this one. Then we find the determinant of these values. And lastly, we simplify the answer. Del w over del y equals to 2y in bracket z plus w over 3z squared.
Alright, for the second question, the question is given fxy equal to 2x square y plus 2x square plus y square minus 2y plus 5 is a surface on the region R. X square plus y square less than 1. A. Find the interior critical point of fxy. Alright, the solution is fxy equal to 2x squared y plus 2x squared plus y squared minus 2y plus 5. We need to find the f with respect to x, which is 4xy plus 4x, and we get the simplify is 4x in bracket y plus 1. Then we let f with respect to x equal to 0, and we get x equal to 0, or y plus 1 equal to 0, then we get y equal to negative 1. Alright, then after that we need to find the f with respect to y, which we get 2x squared plus 2y minus 2, and we simplify and get 2 in bracket x squared plus y minus 1. Then when x equal to 0, we get y equal to 1, and when y is equal to negative 1, we get s plus minus set 2. Therefore, the critical points is 0, 1, set 2, negative 1, and negative set 2, negative 1.
Therefore, there are 3 points, which is 0, 1, set 2, negative 1, negative set 2, negative 1. To classify that, we use second derivative test. We differentiate fx, xy with respect to x, and we got 4y plus 4. We differentiate fx with respect to y, and we got 4x, and we differentiate fy with respect to y, and we got 2. The formula is fsx ab dot fyy ab minus fxy squared. Substitute the value of fxx, fxy, and fyy, and we got 8y plus 8 minus 16x squared as a equation. And then substitute the value of a and b into the equation. For the first point, 0, 1, we got 16, which is bigger than 0, so the point is a local minimum. For point set 2, negative 1, and negative set negative 1, both we got negative 32, which are less than 0. So both points are saddle point. Okay, next question 2b. Find the critical point at boundary of R. The equation is fxy equal to 2x squared y plus 2x squared plus y squared minus 2y plus 5. And the equation gxy is equal to x squared plus y squared minus 1. We use Lagrange multipliers method. So first, we form this function phi equal to fxy plus lambda gxy, and we substitute fxy and gxy, and we got phi equal to 2x2y plus 2x squared plus y squared minus 2y plus 5 plus lambda bracket x squared plus y squared minus 1. Next, we differentiate the equation with respect to x and y. For pi x, we got 4xy plus 4x plus lambda 2x. And for the phi y, we got 2x squared plus 2y minus 2 and lambda 2y. Then we equal those equation with 0 and make as a one equation. And equation fxy equal to 0 as a second equation, and equation gxy equal to 0 as a third equation. From the third equation, let x square as a subject, so we got x squared equal to 1 minus y squared, and make them as a fourth equation.
from equation 1, we get x equal to 0 and 2y plus 2 plus lambda is equal to 0. And then we make lambda as a subset, and then we get the value of lambda, which is the negative 2 minus 2y. And then we substitute the value into the equation. So when x equal to 0, 0 squared plus y squared equal to 1. And then we get the value of y, which is plus minus 1, which make the first two critical points, which is 0, 1 and 0, negative 1. So next we substitute the value of lambda, which is negative 2, negative 2y, and x squared equal to 1 minus y squared. And then substitute both value into second equation, which is 2, 1, bracket 1 minus y squared plus 2y minus 2 plus 2y bracket negative 2 negative 2y equal to 0. And then after simplify the equation, and then we get the value of y, which is 0, and y equals to negative 1 over 3. After we get the value of y, we substitute the value into the equation, and when y equal to 0, we get the value of x, which is plus minus 1, which make another two critical point, which is 1 0 and negative 1 0. And when the value of y is equal to negative 1 over 3, we get the value of x, which is plus minus 2 set 2 over 3, which make another two critical point, which is 2 set 2 over 3, negative 1 over 3, and negative 2 set 2 over 3, negative 1 over 3. So hence, the critical point at the boundary of R have 6 critical points, which is 0, 1, 0, negative 1, 1, 0, negative 1, 0, 2 set 2 over 3, negative 1 over 3, and negative 2 set 2 over 3, negative 1 over 3. So that's our purpose. Thank you.